Hey class, Lieutenant Commander Street back here. This is a video for Nifenav. We are talking about Chapter 6 here. If you haven't noticed yet, we have our 4 pieces of mandatory information if we want to solve for in-flight wind calculation. Okay, so and that is true heading, track, true airspeed, and ground speed. If you don't already know this, you gotta know it. So here we are. We want to compare true heading to track, true airspeed to ground speed, and we're going to use the whiz wheel to basically find out what our wind is. So in-flight winds means we're finding winds, and it's actual winds. All right. Now you can't do in-flight winds without having pre-flight winds, right? And why is that? It's because there's already a given true heading. Okay, you wouldn't have a true heading unless you already had some sort of winds, predictive winds, right? So forecast winds would have been given, and then you would have done a pre-flight wind calculation to determine what that true heading is. Okay. Um, Now you would have calculated a different ground speed than your pre-flight winds, or sorry, than what you have here, this actual ground speed, because you have a different wind. Okay, so unless it's the same exact wind, which you don't know because you're doing a in-flight wind calculation, then you're going to have a different ground speed. Okay. The other thing about ground speed is it's not known for your jet log. All right, I can't make it more clear than that. You will not know your ground speed initially when you go into your in-flight wind calculation. Okay, the reason is because again, you calculated the true heading for your first leg, and it's in your ground speed that you had calculated was based upon pre-flight winds. So the ground speed's different than what it actually is, right? So in reality, you find yourself in a different place, right? So you're going to look at your track instead of your true course. Your true airspeed doesn't change because that's a power setting in your plane. Once you set it, you forget it, right? And then your true airspeed just happens. But the winds change, so then your ground speed's going to be different. And so you're going to have to solve for that. Okay, so what's the equation for ground speed? Since we have to figure it out, ground speed is the speed equation, distance over time. Okay? If that doesn't look familiar, you need to go back to chapter 3, okay? So you have speed, right? And it's just a ratio problem, right? Speed, so ground speed is equal to distance over time, and you'll get these by plotting your position. Once you plot your position, you can plot a course or your track, and the distance is here. And when you slap your clock at the time when you realize where you're at, then that's the time. So it's, hey, I've traveled a certain amount of distance over time, and that gives me speed. So you're going to calculate speed um, or ground speed for your in-flight wind calculation on your jet log. Okay, you might have to do that too for the first 40 questions, but just know that these are the 4 items you must have to calculate in-flight winds. Okay. All right. So now that we know that, we can use our whiz wheel. Now, if you haven't done so, if you haven't studied Chapter 6 yet, you need to go back and you need to look at the ways that we're going to estimate the winds. All right, we have to figure out what portion of the whiz wheel we're going to be looking at. Okay, if we don't, we might be going to the wrong quarter. Okay, so it's always important to do your wind T. When you do your wind T, make sure that heading's at the top. Okay, and so if we have some sort of a drift to the right, we have a crosswind component from the opposite end. Okay, and if our ground speed is less than our true airspeed, we know that we have a headwind. Okay, so again, these are fundamental things that you're going to need to know going into the test, but it needs to be ingrained. You need to know this right off the bat. So if you spend more time on this than you need to, you're going to run out of time. So feel confident in this ability. And that's only going to happen if you study. All right, so we know that if ground speed is less than true airspeed, we have a headwind, cool, and then we have a crosswind, and we know our component's somewhere in here, right? That's where our wind's coming from, okay? If they give you the actual numbers, so if they give you true heading and track, you're just going to take the difference of the two, and that will give you drift angle, okay? That drift angle you will find on your whiz wheel somewhere in here, okay? And just like in pre-flight winds, you will set a wind component, your true airspeed component, above your true airspeed. So this will go here. All right. So say you're flying 150 knots, that's going to go right here. Say your drift angle was 9 degrees. Okay. What we can do right off the bat is our 10% rule off of our true airspeed. So 15 knots will give us 6 degrees of drift angle, or 6 degrees, of drift angle. All right. If you do the 9% rule or 9-degree rule, uh, that's basically adding half of this to 15. So that's 7 plus 15 is 22. But we can also just know that if we have true airspeed set, we can just go to 9 and look up. All right. And we know because it's 9, not 6, that's going to be greater than 15 knots. Right? Because 6 degrees of drift, it gives you 15 per your 10% rule. So 9 degrees will give you more, right? So we're looking for something like 20 some knots of crosswind. And sure enough, here it is. Smack dab between 23 and 24. If that's the case, I'm going to round up. That's what I'm going to do. So if I have more than 23 knots, the halfway point or more, I'm going to round to 24. So I got 24 knots of left crosswind. Okay, another reason why you need to estimate first, because then you'll know, okay, I have a left crosswind, I have a headwind. Okay, you'll compare your true airspeed with your ground speed, because again, you'll have to calculate ground speed, or I'll give it to you. And so you take the difference and say, yeah, you had 150 true airspeed. Your ground speed, and we already said we had a headwind, so let's give it that, a headwind of maybe 20 knots. So it'd be 130 would be our ground speed. So we have a headwind of 20. Okay. So I'm just making this up as we go along, but it makes sense, right? Because if you have a headwind of 20 knots, that means that you have to subtract it from true airspeed, which is 150. So that gives us 130. All right. So headwind of 20 and a left crosswind of 24 knots actual, right? Because we just solved for it here. All right. So once we have those components, 20 and 24, we can plot. Here is a kicker here. So the TC line. The only things you'll put on here for the TC line is anything that sounds like k. It has the k noise. So track and true course. And since true course is not an in-flight wind item, then we're not going to use true course. We use track for in-flight winds. We use true course for pre-flight winds. This is not pre-flight. Okay, so didn't invent the true heading yet, so we'll make one up. Say your heading was 050, all right? That makes our track 9 degrees to the right of that, right? So it's 059, and since track goes on your TC line, we're going to move it to 059. Cool. Now that's there. We can plot our components. And so, again, remember 24 knots, left crosswind, headwind at 20. So what we'll do is, and I don't want to get a pen on my whiz wheel, but 20 knots of headwind, 24 knots of crosswind, right there, okay? When you feel confident that that's where it's supposed to be, go ahead and turn the dot to the top to be able to read off the directions. So I have 009 at, it looks like 30 knots. All right, so you have that, and that can become your new winds for your pre-flight wind calculation that you're going to do for your jet log. Okay, so you're going to hold on to that wind component and continue on for jet logs. For the rest of the problems, for the first 40, you're done, unless they ask you something else. Okay, so but for the most part, in-flight wind calculations, once you figure out the winds, you're done, which is cool. Last thing that I will say about this is that you might think about expanding these components to find a better direction. I know I talked about it in class, but some of you might have forgotten. But when I talk about what I mean by that is if you multiply out these components by, say, a factor of 2 or 3, what you'll do is you'll push these numbers out further on the outside. And what happens to these degrees as you get further and further away from the middle? Well, they get farther and farther apart, which gives you more fidelity, and you can find better directions the further out you are on the edge. Okay, so we're going to do that for this. So I have 24 knots for my crosswinds, times it by 2, so we get 48. Now I have 48 knots, and then I'll have 40 knots for my headwind. So I'll go to 40, walk it across until you get to 48, and then drop a dot. Okay. All right, now that I have that, I go ahead and turn that up, and it looks like I'm closer to 10 degrees instead of 9 degrees. But I could be still on 9 degrees. It's just that my thing is so my marker's so big that I'm having a hard time getting some fidelity here, which is my fault. But I want you guys to see my dots, so I'm using bigger markers. Try this one more time. 40, 48, pow. Yeah, that is on the left side of that 10. All right. Yep, there it is. 009, and it says 62. Yeah, I'd say about 62. So we just divide that by 2 because we times it by 2, and that gives us 31 knots. Okay, so 009 at 31 knots, and that's how you do it. I hope you guys got something out of the video. If you have any questions, text your instructor, and hey, finish this stuff up, get to know it, and get to that jet log. And see you in class.